Let's talk about a cosmic bank account, a fundamental rule that governs, well, everything, from your car engine to the stars in the sky. And the main rule, you can't get something for nothing. Today, we're going to break down one of the most foundational principles in all of physics, the first law of thermodynamics.
At its absolute heart, that's what we're talking about. Thermodynamics is the science of energy conversion. It's all about how energy moves around and changes shape. So think of it less like a mint printing brand new money and more like a currency exchange. You're not creating energy from scratch. You're just swapping it for a different form.
And yeah, like any system that actually works, it has rules. And these, well, they're unbreakable. To really get a grip on them, we've got to travel back in time a bit, to an era of smoke, steam, and some absolutely incredible invention.
And the story of these rules, it all kicks off with a really practical problem, a big one, the problem of power.
I mean, just picture it. You've got inventors like James Watt building these amazing steam engines that are powering entire factories, moving trains. They were revolutionary. But here's the crazy part. On a really deep scientific level, nobody was totally sure why they worked. The engineering had just leapfrogged way ahead of the physics, and scientists were scrambling to catch up, to figure out the principles behind all this new power.
Okay, so before you can write the rules for a game, you need to define the pieces, right? Well, scientists needed a new language, a way to talk about energy with some real precision. So they started by defining exactly what it was they were studying.
And this is the absolute first step, the key concept, a system. It's really just whatever we decide to draw an imaginary box around to study. That box could be a piston in an engine, a can of soda. Heck, it could even be a single cell in your body. And everything outside that imaginary box, we just call that the surroundings. Simple, right? But this allows us to carefully track what goes in and what comes out.
And you know, these systems basically come in a couple of flavors. First, you've got a closed system. Think of a sealed can of soup. You can heat it up, so energy can definitely cross that boundary. But no matter, no soup can get in or out. Then you've got the opposite, an open system, like a pot of boiling water. Not only are you putting energy in to heat it, but matter is actually leaving in the form of steam.
All right, so we've got our system. How does it actually interact with everything else? How does it talk to its surroundings? Well, it turns out there are really only two main ways: work and heat. This is the universe's currency exchange in action.
Okay, now this next part is super important, a really key distinction. Some properties, like temperature or pressure, those are what we call point functions. It doesn't matter one bit how a system got to its current temperature, it just is that temperature right now. But work and heat, those are different. They're path functions. The amount of work you do or the heat you transfer depends entirely on the journey you took to get there. It's kind of like this. Your final destination, that's a point function. But the actual route you took, the miles you drove, that's a path function.
And look, this visual right here illustrates that perfectly. We're trying to get a gas from state 1 to state 2. You could take path A, B, or C. The start and end are identical, right? But look at the area under each curve, which represents the work being done. It's totally different for each path. The path literally changes everything.
So, with all these pieces on the board, systems, work, heat, path functions, scientists were finally ready. They were ready to figure out the one master rule that tied it all together.
And this is it. This deceptively simple-looking device from James Joule. It literally changed everything. It's just so brilliant. You've got a falling weight, doing mechanical work, turning this little paddle wheel inside a sealed container of water. Joule measured everything with incredible precision, and what he found was incredible. The amount of work done by that falling weight was directly, perfectly proportional to how much the water's temperature went up. He had proved, beyond a doubt, that work could be turned into a predictable amount of heat.
You have to understand, this was a huge deal, a total paradigm shift. See, before Joule, a lot of scientists bought into this idea called caloric theory, that heat was this invisible, weightless liquid that just flowed from hot things to cold things. Joule's experiment just blew that whole idea out of the water. Heat wasn't a substance, it was a process. It was energy in transit.
And once they realized that work and heat were just two different sides of the same energy coin, well, that led them straight to one of the most profound, most powerful principles in all of physics.
And there it is. Looks so simple, right? But wow, is it profound. Let's really break this down.
Okay, let's go right back to that bank account idea because it fits perfectly. Delta E, that's the change in your system's internal energy, its total account balance. Q is the heat you add to it. Think of that as a deposit. W is the work the system does on its surroundings. That's a withdrawal. So the change in your balance, it's just your deposits minus your withdrawals. Seriously, that's it. That's the whole law.
And that simple bit of math is what gives us the famous line we all remember from science class, right? You can't just create energy out of thin air, and you can't make it vanish into nothing. All you can ever do is change its form, from chemical to mechanical, from mechanical to thermal. The books always have to balance.
And this right here is why the dream of a perpetual motion machine, a device that just runs forever on its own, is completely impossible. It's like trying to have a bank account where you only ever make withdrawals but never make a deposit. The first law just puts its foot down and says, nope, not going to happen. You simply cannot cheat the cosmic bank.
Okay, fine, so this was all figured out back in the 1800s. Cool story, but why should we care about it today? Well, because this law, it's the foundation for pretty much all of our modern technology.
I mean, really think about it. A power plant, it's just a massive heat engine following this rule. Your car's engine, same thing. A jet engine, your fridge, your AC, they're all just incredibly clever ways of applying this one simple rule of energy accounting. Heck, our own bodies are thermodynamic systems, turning the chemical energy in our food into the heat and work we need to just live. It is literally everywhere.
And that kind of leaves us with this one big final question, doesn't it? If the total amount of energy is fixed, and all we can ever do is change it from one form to another, then the single biggest challenge for us, for our future, is figuring out the best, the smartest, the most sustainable ways to make those transformations. The law itself is set in stone, but the choices we make, well, those are entirely up to us.